To find the percentage error in the area of an ellipse if there is an error of 1% each in measuring major axis and minor axis. Now, error in major axis is given as 1% and error in minor axis is given as 1%, and we have to find the error in the total area. So we know that major axis is nothing but 2a and 2b is the minor axis, and they have given that percentage error on major axis, that is delta A by 2a into 100 is given as 1, and also delta B by 2b into 100 is given as 1%. Now we need the corresponding percentage error in total area of the ellipse. Now here we can write this as delta A by A into 100 can be written as 2. Similarly, delta B by B into 100 can be written as 2. Now area of ellipse is nothing but pi AB. So area of ellipse is pi AB. We'll apply logarithm on both sides. Logarithm of A equals logarithm of pi plus logarithm of A plus logarithm of B. Now let us differentiate this. If I differentiate, it will be delta A by A, that is equals to 0 plus delta A by A plus delta B by B, and let us multiply 100 throughout the equation. The reason is we need to find percentage error. Delta A by A into 100 equals to delta A by A into 100 plus delta B by B into 100. Now this will be nothing but 2 plus 2, which is equals to 4. So there is a change of 4% on area, which is option C.
BIOS configuration shown below has the following specifications. That is, this is ICQ is equals to half IC-SAT. IC-SAT is nothing but 8 milliamps. VC is equals to 18 volts. Beta equals to 110. We have to find the value of emitter resistor RE. Here ICQ is nothing but 28 minus 18 divided by RC. We know ICQ is nothing but half of IC-SAT, that is 4 milliamps. So RC we will get it as 10 by 4 kilo ohms, that is 2.5 kilo ohms. IC-SAT, which is equals to 8 milliamps, is equals to VCC, that is 28 volts, minus VCE-SAT, which we are considering as 0 here, divided by RC plus RE. So RC plus RE, 28 divided by 8. Here RE is nothing but 28 by 8 kilo ohms minus 2.5 kilo ohms, which is nothing but 3.5k minus 2.5k, which is 1 kilo ohm. Hence option A is correct. Find the Nyquist sampling rate for the signal. X of t is nothing but sinc of 200t multiply with sinc square 1000t. So in order to decide Nyquist sampling rate, we have to know the what is the maximum frequency content present in the signal x of t. So suppose sinc 200t is represented in time domain like this. In frequency domain, the band of frequencies are 100 Hz to minus 100 Hz. This is F, whereas sinc square in frequency domain is represented as in this way. This is frequency 1000 Hz minus 1000 Hz. But in time domain, sinc 200t and sinc square 1000t are multiplied. Means in frequency domain these two signals are convolved. That means the lower limits are added together and the upper limits are added together. So the maximum frequency content in the convolved signal is nothing but 1100 Hz. So the Nyquist rate for this particular maximum frequency twice into f max, that is 2200 Hz. Hence option B is correct. The solution of the initial value problem: y dash plus 3y plus 2 integration 0 to t y dt equals to t, and the y of 0 equals to 0. So if we apply the Laplace transformation on both sides of the above equation, we will get s y of s 3y of s plus 2 by s y of s is equals to 1 by s square. So s square plus 3s plus 2 y of s is equals to 1 by s. So from this, y of s is nothing but 1 by s f of s. Here f of s is 1 by s plus 1 s plus 2. So now y of t is nothing but integration 0 to t f of t dt. So 0 to t e power t e power minus t minus e power minus 2t dt, which is nothing but minus e power minus t plus e power 1 by 2 minus 2t 0 to t. So if we substitute e power minus t plus 1 by 2 e power minus 2t minus of minus 1 plus half, so we will get this as 0.5 e power minus 2t minus e power minus t minus means plus 0.5, which is option B is correct. D is correct. The figure shows the block diagram of a feedback control system where A equals to 30 at angle 60 degrees, B is equals to 60 at angle 30 degrees at a certain frequency. The value of the block C for the system to oscillate is. So in order to decide the value of C, we have to first of all find out the closed loop transfer function, that is C of S by R of S. If we find, we will get it as, that is we can write G of S by 1 plus G of S H of S. So here G of S is AB by 1 plus A, H of S is C. So C of S by R of S is equals to AB 1 plus A divided by 1 minus ABC divided by 1 plus A, which is nothing but AB 1 plus A minus ABC. So for the system to oscillate, 1 plus A minus ABC should be 0. That is, C is nothing but 1 plus A by AB, which is equals to 1 plus 30 at an angle of 60 degrees divided by 1800 at an angle of 90 degrees, which is leads to 0.0169 at an angle of minus 31.68. So the magnitude of the block C is nothing but 0.016, that is option C is correct. As